So you have taken an old exam one, and now you're watching this video and grading your solutions. So the first piece says solve for the following equations. The first one, we have x times the quantity x minus 4 equals 12. And so solving this, I need to first distribute my x. And so distributing x, I have x times x is x squared. X times negative 4 gives me minus 4x. This is equal to 12. I notice this is a quadratic equation. And so one way I can solve this is setting it equal to 0. So let it subtract 12 on both sides. Doing that, we get x squared minus 4x minus 12 equals 0. There's different ways that we could approach this. I would factor it if possible, which this one is. If not, you can go ahead and you can either complete the square, you can use the quadratic formula, but we're going to go ahead and factor this. There are two numbers that multiply to give me negative 12 and add to give me negative 4. And those two numbers are negative 6 and positive 2. So we can factor this as x minus 6, that quantity times the quantity x plus 2, that's equal to 0. Set each factor, x minus 6 equal to 0 and x plus 2 equal to 0, and solve. We get x is equal to 6 and x is equal to negative 2. Next question says, if k is equal to k plus 3 all over, if k is equal to x plus 3 all over x minus 4, and k squared minus 3k minus 28 equals 0, find x. So first thing that we would like to do is we want to solve for k. In this equation, k squared minus 3k minus 28 equals 0. I notice again that that is factorable. There are two numbers that multiply to give us negative 28 and add to give us negative 3. And that would be a negative 7 and a positive 4. And so this factors as x minus 3, that quantity times the quantity x plus 4 equals 0. Setting each factor equal to 0 and solving, I have x minus 7 is equal to 0, and that is when x is 7. And I have x plus 4 is equal to 0, and that is when x is equal to negative 4. So now we're going to the equation k is equal to x plus 3 all over x minus 4. We are going to plug in what we solved for k. And I apologize, but these were k, not x, at the beginning. So we have k equals 7 and k equals negative 4. So we're going to have two separate equations. We're going to have 7 is equal to x plus 3 all over x minus 4. We're going to solve for x there. And we have negative 4 is equal to x plus 3 all over x minus 4. Solving that first equation there, we have a rational equation. So let's clear our fractions. And we can do so by multiplying both sides of our equation by x minus 4. Denominator cancels on the right-hand side. Let's distribute our 7 to x minus 4. So 7 times x is 7x minus 7 times 4 is 28. This is equal to x plus 3. I notice this is a linear equation, so I want all my terms with x to one side of the equation, all my terms without the x to the other side. So let's subtract x on both sides. We get 7x minus x is 6x. And let's add 28 to both sides. So 28 plus 3 gives me 31. Divide both sides by 6, we get x is equal to 31, 6. So that's one solution. Solving the other equation, rational equation, negative 4 is equal to x plus 3 all over x minus 4. We're going to clear the fractions again by multiplying by our least common denominator, which is x minus 4. Just put it over here. Let's distribute our negative 4 on the left-hand side. So negative 4 times x is negative 4x. Negative 4 times negative 4, that gives us plus 16, is equal to x minus 4's cancel, x plus 3. So again, we want to get all the terms with x to one side, constants to the other. So let's subtract x on both sides. Negative 4x minus x is negative 5x. And let's subtract 16 on both sides. So 3 minus 16 is negative 13. Divide both sides by -5. A negative divided by a negative is positive. So we get x is equal to 13/5. So those are our two solutions. The next equation, I have 2 times x raised to the -2 power minus 3 times x raised to the -1 power minus 4 equals 0. There's multiple ways, again, I can approach this. I could rewrite this as 2/x² minus 3/x minus 4 equals 0. Clear my fractions by multiplying 3 by x². Instead of doing that, I noticed that I can manipulate this to look like a quadratic, and I could use substitution here to solve. So I'm going to do that. I am going to rewrite this. This is the same thing as 2x to the -1 power squared minus 3 times x to the -1 power minus 4 equals 0. So let's u equal x to the -1 power. Doing so, we now have a quadratic. 2 times u squared minus 3 times u minus 4 is equal to 0. Unfortunately, that number in front of my square term is not a 1. And so let's go over here on the side to do some work. I'm going to do the AC method. So I'm multiplying a, which is 2, times c, which is -4, is -8. We're trying to find two numbers that multiply to -8, but would add to -3. I see that that does not work. So I feel like that this was probably an error, and I probably changed this when it was on the exam. -8. So in this case, I would technically, and if I didn't change it on the exam, I would have to go through and I would need to use my quadratic formula to solve for u. I'm going to change this problem because I wouldn't have done that to you. I apologize about that. Let's change this to a 2, and this to a 2, this to a 2. If that's the case, then this actually is factorable. I can factor out a 2 from all of our terms, which is u squared minus u minus 2 equals 0. We can factor u squared minus u minus 2. That factors as u minus 2 times u plus 1 equals 0. So u is either equal to 2 or u is equal to -1. The thing is, I don't want u, I want x. So let's go back in and plug in what u was and solve for x. So I have 2 is equal to x to the -1 power. Couple ways I can think about this. I know power to power exponents is multiplication. I really want that x to the first power. So I can do that by raising both sides to the -1 power. Make that exponent positive. 2 to the -1 power is the same thing as 1/2 is equal to x. For u equals -1, I have -1 is equal to x to the -1 power. Another way that you could have approached this is rewrite x to the -1 so that it has a positive exponent. I can rewrite that as 1/x. Now I can clear my fractions by multiplying both sides by x. There I would get -x is equal to 1. Divide both sides by -1. I would get x is equal to -1. So there we have two different solutions for part C. Our next problem says, given the piecewise function below, answer the following question. The square root of x, square root of -x minus 2. And this here, it's covered up, but this should be x is less than -2. We have -1 if x is between -2 and including and less than 1, bigger than -2 and less than 1, and absolute value negative in front of that absolute value of x minus 3, and the absolute value minus 3 if x is greater than 1. Okay, so we want to graph this. We want to graph each piece of our equation. So let's look at the equation y equals the square root of negative x minus 2. If I plug in a negative 2 there, even though it's not included, I always want to see what's going on the end values of my inequalities. So plugging in negative 2, again, square root of negative 2 is positive 2. Positive 2 minus 2 under the radical is 0. Square root of 0 is 0. I'm going to put an open circle here because it's not included, but we're getting very, very close to x equals negative 2 on the left. Choosing a number that is smaller than negative 2. How about negative 6? So if I plug in negative 6 there, I get the square root of negative 6, which is positive 6. Positive 6 minus 2 is the square root of 4. Square root of 4 is 2. So let's plot that. So at negative 2, I have an open circle at 0. At negative 6, I have a positive value. Y is 2. And so my graph of that piece is going to look like this. Looking at the second equation is f of x equals negative 1. So I know that's the same thing as y equals negative 1. That's going to be a horizontal line between negative 2 and 1. At x equals negative 2, I have negative 1. So that is going to be solid. And at x equals 1, it's not included. So that's going to be an open circle. And for the last equation, so let's go ahead and plot some of that. I have y is equal to negative absolute value of x minus 3 and absolute value minus 3. So this is for x greater than 1. I want to see what's happening at 1. If I plug in 1 into the absolute value, I have 1 minus 3, which is negative 2. Absolute value of negative 2 is positive 2. But I have that negative out front. So I have negative 2 minus 3, which is negative 5. If I plug in 2, and this is going to be an open circle because it's not included with that inequality. If I get x equals 2, I would have 2 minus 3 inside the absolute value, which is negative 1. Absolute value of negative 1 is 1, with a negative out front is negative 1, minus 3 is negative 4. If I plug in 3 here, 3 minus 3 is 0. 0 minus 3 is negative 3. Let me just go a little bit further. How about 4? 4 minus 3 is 1. Then with a negative out front, it's negative 1 minus 3 is negative 4. Okay, so at 1, negative 5, I have an open circle. At 2, negative 4, I have a point. At 3, negative 3, I have a point. At 4, negative 4, I have a point. And so it looks like kind of like a V shape. And it comes down like this. Next question asks, what is f of negative 3? So we want to know what is our y value when x is negative 3. So looking at our inequalities for each equation, we want to find the one that satisfies x equals negative 3. Well, I know negative 3 is less than negative 2, so that tells me that I'm going to use the first equation. And so this would equal the square root of negative, plugging in negative 3 where I see an x, negative 3 minus 2. So this is equal to the square root of 3 minus 2, which is the square root of 1, which is equal to 1. We want to find the y-intercept. Looking at our graph, I can see that my y-intercept here is at negative 1. So 0, negative 1 is the point where we're crossing the y-axis. Finding any x-intercepts, looking at this graph, there's no x-intercepts. Next question says, answer the following questions. For x squared plus y squared plus 6x plus 8y minus 24 equals 0. Put the equation of the circle in standard form. That is, rewrite the equation to be in the form x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, so I notice I have a perfect square for my x terms, a perfect square for my y terms. So what I want to do is I want to group my x terms together. I want to group my y terms together, get the constant on the other side. So rewriting my equation, I'm going to do that. I have x squared plus 6x. I'm going to leave room here because I'm going to add a number here to make it a perfect square in a minute. Then grouping my y terms together, I have y squared plus 8y. I'm going to add something here to make this a perfect square. So I'm going to leave a space there. Is equal to, I'm adding 24 to both sides of my equation. And then whatever I added on the other side of the equation, I'm going to have to add to the right-hand side of the equation to make it equivalent. So trying to figure out what I need to add to x squared plus 6x to make that a perfect square. Take half of 6, which is 3, and square it. That gives me 9. So I'm going to add 9 to both sides to make the x terms a perfect square. To find what I need to add to make the y terms a perfect square, I'm going to half 8. 8 divided by 2 is 4. Square that 4. That's 16. So I'm going to add 16 to both sides of my equation. So now I can rewrite this. This is x plus 3 quantity squared plus y plus 4 quantity squared. This is equal to 24 plus 3, that's 33. 33 plus 16 is 49. So my center of the circle is HK. It's opposite signs of what's inside the parentheses. So it's going to be -3, -4 is my center. My radius, well, what we have on the other side, 49, that's r squared. So the square root of 49, my radius is going to be 7. Find the x-intercepts. If it has an x-intercept, then this is where y is equal to 0. So let's go back in. I'm going to plug it into my perfect square. So x plus 3 quantity squared plus 0 plus 4 quantity squared is equal to 49. So I have x plus 3 quantity squared plus 4 squared is 16 equals 49. I'm going to use the square root method. So I'm going to isolate my perfect square by subtracting 16 on both sides. If I do so, I get x plus 3 quantity squared is equal to 33. Now we can take the square root of both sides. If we take the square root of both sides, don't forget the plus or minus in front of the square root. So taking the square root of x plus 3 quantity squared is x plus 3 equals plus or minus the square root of 33. Get x by itself, subtracting 3 on both sides, I get -3 plus or minus square roots of 33. So there's two values where it's crossing the x-axis, -3 plus square root of 33 and -3 minus square root of 33. To find the y-intercepts, if they exist, that is when x is equal to 0. So we're going to set x equal to 0 and we're going to solve for y. So going again into the perfect square, I have 0 plus 3, or standard form. Squared plus y plus 4 quantity squared equals 49. 3 squared is 9 plus y plus 4 quantity squared is 49. Let's get that constant of 9 on the other side. Subtracting 9 on both sides, we have y plus 4 quantity squared equals 40. Using my square root method, taking the square root of both sides of my equation, and the square root of y plus 4 quantity squared is equal to plus or minus the square root of 40. So I have y plus 4 is equal to plus or minus. I notice that 40 can be broken down as 4 times 10. Square root of 4 is 2, so I'm pulling that outside of the radical, and I have a 10 left underneath the radical. Let's subtract 4 on both sides of our equation. We get -4 plus or minus 2 root 10. So those are my y-intercepts. If you want to get an estimate, we can plug that into the calculator. That might help us with graphing it a little better. So -3 plus square root of 33 from the x-intercepts above. That would give me approximately, x is approximately 2.7. If I did -3 minus the square root of 33, I get that as approximately -8.7. Finding my y-intercepts, if I did -4 plus the square root, I'm just going to put 40 in there. That is 2.3. And -4 minus the square root of 40 is y is approximately -10.3. The next question wants us to graph this. We had a radius of 7. We had a center of the circle of -3, -4. So let's find the center of the circle first, -3, -4, which is about right here. I know I want to go up 7, down 7, to the left 7, to the right 7. If I go down 7 from -4, it's not on here, but it's -11. If I go up 7 from -4, that would give me a y value of 3. If I went to the right if I went to the right 7 from -3, that would give me an x value of 4. And if I went to the left 7, subtracting 7 from -3, that would give me -10. So let me just go in, because since we found it, let's approximate. We said approximately 2.7 for my x-intercept. I'm just going to put it in here, and -8.7. So I'm just going to estimate it. My y-intercepts was 2.3 and -10.3. Now drawing my circle. And get the following. What is the domain and range? The domain are all the x values I'm hitting on the graph. All the x values I'm hitting on the graph include -10 and go to +4. All the y values, the range, all the y values I'm hitting on that graph, the smallest y value I'm hitting is -11. And I'm going up to the max y value I'm hitting is +3. The next problem says let f of x equals 2x minus x squared. Answer the following question. Find f of -4. So that's letting me know wherever I see an x in my equation f of x, I'm going to drop in -4. So f of -4, I'm going to go in and put parentheses wherever I see an x, and then I'm going to drop in -4 inside that parentheses. So 2 parentheses minus parentheses quantity squared, putting in -4 inside the parentheses, using order of operations to help me simplify this. 2 times -4 is -8, minus -4 quantity squared is 16. -8 minus 16 gives me back -24. In your own words, what does f of -4 represent? Well, this is saying what is our y value when x is -4? Another way to say that is we have -4, -24 is a point on our graph of f of x. Find all values of x such that f of x is equal to -24. So here we're going to take our equation 2x squared. And no, it's not 2x squared, 2x minus x squared. We're going to set this equal to -24. I see that this is a quadratic equation, so I want to get everything to one side of my equation and set it equal to 0. I prefer to have a +1 in front of my x squared, so I'm going to add x squared and I'm going to subtract 2x on both sides. Adding x squared, I'd have x squared, subtracting 2x, I have -2x, minus this 24 is equal to 0. I notice this is factorable. There are 2 numbers that multiply to give me -24 and add to give me -2. That would be -6 and +4. So I can factor this as x minus 6 all times x plus 4. Setting each factor equal to 0, solve x minus 6 equals 0 and x plus 4 equal to 0. We get that x is equal to 6 and x is equal to negative 4. Find the average rate of change between x equals negative 4 and x equals negative 2 on f of x. So I need to find the points when x is negative 4, and I need to find the point when x is negative 2. Well, above, we already found f of negative 4, and that was equal to negative 24. So I have a point here, negative 4, comma 24. Same thing, I want to find out what f of negative 2 is. So I'm going to go into my equation f of x. Wherever I see an x, I'm going to first put a parentheses. So 2 parentheses minus parentheses squared. Go in, drop in negative 2 wherever you see a parentheses. And now simplify by order of operations. I have 2 times negative 2 is negative 4 minus negative 2 quantity square is positive 4, but I have the minus out front. So negative 4 minus 4 is negative 8. So I have a point here at negative 2, negative 8. So now I want to find the average rate of change on f of x. So I want to find the slope between those 2 points, the line that joins those 2 points. So I'm looking at the change in my y value. So 24 minus 8 all over the change in my x value. I started with my first point with my y value. So I need to start with the first point with my x value. So now you get a 4 minus a negative 2. So let's simplify that. 24 minus 8 is 16. All over negative 4 plus 2, which is negative 2, is negative 8. So my average rate of change between x equals negative 4 and x equals negative 2 is negative 8. Find the line that is joining the points f of x equals on f of x at x equals negative 4 and negative 2. Well, we just found the slope of that line. So we have the slope of that line, which was negative 8. And let's choose one of the points. It doesn't matter which one. I'm choosing the one with smaller numbers, negative 2, 8. You can either use your point slope formula, or you can do what we've been doing in class and plugging in our point and our slope to figure out what our b value is, that y-intercept. So my value on my point, y is 8, is equal to my slope negative 8 times my x value negative 2 plus b. So I have 8 equals negative 8 times negative 2 is positive 16 plus b. So subtracting 16 on both sides, I get b is equal to negative 8. So I know what my slope is, I know what my y-intercept is, so now I have the equation of the line joining those 2 points. It is y equals negative 8x minus 8. Next, we want to find the difference quotient of f of x. I give you what the difference quotient is. That is f of x plus h minus f of x all over h. Let me just bring down again what f of x is. F of x, we said, was equal to 2x minus x squared. So this f of x plus h, I'm going to go in wherever I see an x. Let's put parentheses, but big enough to replace it with x plus h. So I have 2 times parentheses minus parentheses quantity squared. Drop in x plus h inside our parentheses. And that is just the first piece of the difference quotient, f of x plus h. I want to subtract off my whole function f of x. Make sure you have parentheses around that whole thing. 2x minus x squared, because we're going to have to distribute that negative. And we're putting this whole thing over h. So now let's go through and let's distribute and combine like terms. I notice I can distribute my 2 to the x plus h. That would give me 2x plus 2h. Minus, I'm going to distribute out x plus h times x plus h. If you do that, you get x squared plus 2xh plus h squared. And then let's distribute that negative inside the bracket. So negative 1 times 2x is minus 2x. Negative 1 times negative x squared is plus x squared. And then we're putting this all over h. Let's distribute our negative sign inside this parentheses here and combine like terms. So 2x plus 2h. Now distributing my negative, I have minus x squared minus 2xh minus h squared. Copying down another piece, negative 2x or minus 2x plus x squared all over h. Cancel out terms that are like. I notice I have a positive 2x and a negative 2x. Those cancel. I have a negative x squared and a positive x squared. Those cancel. I notice that all the terms that are left in the numerator all have an h in common. So I can factor out the h in the numerator. And if I do so, I would be left with 2 minus 2x minus h all over h. Now that we had rewritten this so it's multiplication, in between that h and that parentheses, we can cancel our h's out, and our difference quotient we found was 2 minus 2x minus h. The next piece says, is f of x even function, an odd function, or neither? An even or odd function show mathematically. So let me rewrite down again what f of x is. F of x was 2x minus x squared. If it's an even function, I know that f of, plugging in negative x wherever I see an x, and simplifying, I would get back my original function f of x. If it's an odd function, f of negative x, plugging in negative x wherever I see an x and f of x, this would equal negative of f of x. So I notice both the even and odd functions both have f of negative x in there, so that's the first thing I would check. Let's evaluate f of negative x, plugging in, again, negative x, wherever I see an x, I would have 2 times negative x minus, parentheses, negative x quantity squared. So this would give me back negative 2x minus x quantity squared. Negative x quantity squared is x squared. I notice f of negative x, that does not equal my original. So it's not even. So now let's look at what is negative f of x. That's just telling me I'm multiplying my whole equation f of x by negative 1. So putting a negative in front of my equation, which was 2x minus x squared. Distributing my negative 1, I get negative 2x plus x squared. If I look at this, this is not exactly the same thing as f of negative x, so this is not odd. So f of x is neither even or odd. The next problem in front of us, we're given a graph of f of x, and we're going to answer questions about the graph of f of x. I notice there's no arrows on the endpoints of those graphs, so that tells me that I'm stopping there. Assuming that my tick marks are representing 1 unit each way, I notice that my x value that I'm starting with here is negative 3, and the x value that I'm ending at is positive 3. So my domain and interval notation, I'm including negative 3, so put a bracket, negative 3 comma 3. If it didn't say, I could have written this in inequality notation. Negative 3 is less than or equal to x, is less than or equal to 3. The range are all the y values that I'm hitting on this graph. And so if I look at this, how many places am I going down? I'm going down negative 3. Smallest y value that I hit is negative 3, so bracket negative 3. And the largest y value that I'm hitting on this graph is 1, bracket. Or I could rewrite this as negative 3 is less than or equal to y is less than or equal to 1 for inequality notation. Now we're looking at where is the graph decreasing. The graph is decreasing as we're looking at it going from left to right. It's going down from left to right here. And we're using the x values where that is occurring. So smallest x, where we're starting, where it's decreasing, is negative 3. I'm going to include it just because it's a point on the graph. And we're stopping at x equals -2. I'm going to put parentheses there. I notice that it's also decreasing here, starting at x equals 1, so parentheses 1, and I'm sorry, not 1, I'm starting at x equals 0, ending at x equals 1. And then I also see that it's decreasing here from x equals 2 to 3, so parentheses 2 to 3. Where is the graph increasing? Well, that's where we're going up left to right. So I'm starting at -2, so -2, so parentheses -2, and I'm stopping at 0. Union, I'm also starting at 1 and stopping at 2. Where is a local minimum points? So minimum points, that's where we're decreasing to increasing. It's asking for the point or points. So my x value at the minimum is -2 and my y value is 3. I notice I also have a minimum point here when x is 1, y is 0. Maximum, I see here that I have a maximum point. That's where we're increasing and then decreasing at x equals 0 and ending at x equals 1. And I have a maximum here at x equals 2, 1. I forgot to look at the n values. Notice my n value here at -3, 0 is also a maximum. So I'm going to say also -3, 0 is a local max. Over here, my endpoint on the right-hand side of the graph is +3, 0. That is a minimum value, so I'm going to add it there, 3, 0. Wants to know what f of 2 is. So that's asking me what is my y value when x is 2. Well, looking at this graph, my y value when x is 2 is 1. Find all the x such that f of x equals 0. So I want to look at what x values give me a y value of 0. Another way to state that is, what are my x-intercepts? Well, my x-intercepts occur when x is -3, when x is 0, when x is actually not 0. Unless that goes through, I can't tell. Nope, so let's just estimate that right there. That is a quarter, -1/4. 1 and at 3. So we have 4 values of x's that give us a y value of 0. Would the graph of -f of x be increasing or decreasing or neither on the interval from -1 to 0? Okay, -1 to 0. So I'm looking at my graph. Let me just erase this. From -1 to 0 is this piece right in here. My y value, my x values are going to stay the same. That's going to make a reflection across the x-axis. If I make a reflection here across the x-axis, notice that it looks something similar to this. And so going left to right, that reflection is decreasing. So the graph of -f of x would be decreasing on the interval from -1 to 0. We haven't covered this piece yet, but I'm just going to kind of go through it really quickly, just because if someone's watching this and has covered transformational functions, then they might be able to follow through. So looking at this, I notice I have a horizontal shift. My horizontal shift, I'm going to call it HS, is to the left 2 units. I notice I have a negative in front of my f of x. That's going to be a reflection. Changing my y values, the signs, is a reflection across the x-axis. And then that -3 out here, that -3, this shifts. It's a vertical shift. We're taking a vertical shift down 3 units. Left 2 units. So those of you in my class that are grading this right now for fall 24, this is not going to be on your first test, this J piece, but everything else you should know how to do. Graph the following. I'm not going to graph it just to save us some time because you haven't done that yet in this class. So let me find the last page that you had to do. Found it. So we're looking at finding the domain of f of x equals the square root of 8 minus 4x. That radical is all over x squared minus 16. Finding the domain, we want to look at our trouble spots. We can't have a negative underneath an even-powered radical and get back a number. So we need to set what's underneath that radical. In this case, it's in the numerator, so it could equal 0. If that radical was down in the denominator, it could not equal 0. But we want to find when is 8 minus 4x greater than or equal to 0. Let me add 4x to both sides of that equation. I get 8 is greater than or equal to 4x. Let's divide 3 by 4. That gives me that x has to be, well, it says 2 is greater than or equal to x. I tend to like my x on the left-hand side, so x is less than or equal to 2. Okay, that's part of my domain, but I also see that I have some variables in the denominator. So I'm worried about when is my denominator equal to 0. And so x squared minus 16 cannot be 0. I notice that that factor is x minus 4, x plus 4. X cannot be 4 or x cannot be negative 4. So for my domain for the radical, x had to be less than or equal to 2, but I noticed that x can't be negative 4 and negative 4 is less than negative 2. So if I was to put this in interval notation, I'm looking at negative infinity going up to negative 4, not including, so parentheses, union, parentheses, negative 4, all the way up to positive 2, and we can include 2. So this is our domain. And the last question on this practice test that you are taking, an old exam I've given, if the absolute value of x plus 4 is less than 2, and we're given then a is less or equal to 3x minus 1 is less than or equal to b, we want to find a and b. Okay, so what I want to try to do is I want to manipulate what's inside my absolute value to look like 3x minus 1. I'm going to drop my absolute value. I noticed to drop my absolute value, since this is a less than sign, that would be sandwiched in between the negative of the one side. So negative 2 is less than. X plus 4 has to be less than 2. How about let's get x by itself first inside the absolute value. And so let's subtract 4 on all the sides. If I do that, I get that negative 2 minus 4 is negative 6. So negative 6 is less than x is less than negative 2. I notice I want a 3x. So I notice I can multiply everything on each side of the inequalities by 3. Doing so, we would get negative 18 is less than 3x is less than negative 6. I also notice that I want 3x minus 1 in between those inequalities. So if I subtract 1 on all 3 sides, I would get here that negative 19 is less than 3x minus 1 is less than negative 6 minus 1 is negative 7. So A would have to be equal to negative 19 in this case, and B would have to equal negative 7. So if you're in my class, fall 24, and you're grading your practice test, I want you to go through, give yourself points next to each problem. You saw how many points that was worth. When you do that, sum how many points you got for each piece, put that grade on top of your first page of your graded version of your practice exam, and you're going to submit that to Canvas. I hope this was helpful.